Hello teacher, my name is Al-Amine. This is about the first homework about microcontrol exercise. So let's get started. As you can see, um, I have set up all about the codes in here. So let's begin expand line by line. As you can see from here to the SGMP start, this is the routine that we've been using into the KLE Vision to write our code down. And so the next one is about this code will read the input number and from port 0. The next line is about loading the devices 7 into the register B. So here we can perform the division using the 1851 built-in division operation. Um, After division, we'll get two different answers clearly. So the quotient goes to into A, and also the remainder is stored into A. So the next line, the two next line, is about sending the remainder to the port 1, and the accumulator will be to the port 0, and here the SGMP start, and the end will be the infinite loop to keep the result displayed. So let's rebuild it because I've built it earlier on to test if the code is working or not. So as you can see here, there is zero error, but we have three warnings, and the warning here doesn't matter. So let's debug the system. Well, after debugging, we can see all things are well going in here, and we can start taking out into the periphery the port 0. And so here in this exercise, it's asking us about dividing a number by 7. For example, let's take the number 8. From the system, this is 10. So I think 8 will be here. So this is the number 8. 8 divided by 7, we can get the remainder of 1. So let's text it and see if we can get this remainder of 1. So start from here. Here 8 divided by 7 will definitely give us, and here the remainder of 1. We can go on and see. So the remainder of 1 into the accumulator A and the register B, of course. So from here we can take also out the port number 1. This is the port number 1. We can place it here, and let's say we just pick here the remainder 1, and we can play a little bit with those numbers. For example, let's take from here to here to get the 7. Here we've got the 7 to the into the port 0, and the 1 into the port 1. So what we are expecting from here is to get a 0 into the accumulator and 1 into the register. So let's move line by line to see if we can get this accuracy of numbers. Yes, after that, definitely we've got here 0 into the accumulator A and 0 into the register B. So this is all about the homework number 1. So let's move into the second one. Well, here let's dive into the second exercise. So here, as we've said before, those are the routine into the 1851 microcontroller KLU Vision using to write code. So let's start from here. This will be our first line. So this line will set R0 to source address 18 hexa. The second one will set the R1 to destination address 29 hexa, of course. Here we can come to the third line, which has R2 and 10 decimal. This line will initialize the loop counter 10 byte to transfer. Of course, the next one will fetch data from the source address, and also the R0, which will be selecting from the port 1. And the next one, store data in the destination address R1. We can come to the decimal here, decimal R0 and R1. Those two pointer will move source from pointer backward from 19 hexa, 18 hexa, and so on. So the another one will move the destination pointer backward also as the same, but from 29 hexa, 28 hexa, and so on. We can count until the 10. And here the DG and Z will have an essential role in here because it will decrement R2 and loop until it reach 0. Here the decrementation will be so important. So we can end this SGMP, which is the infinite loop to keep the result displayed and the end of our code. So here let's build it or rebuild it. Yes, you can see we have zero error here, so we can have the access to debug the system. so we don't need those ports in here, so I can erase them. So here the code, let's get the memory. From the memory here you can get the table. This was the memory. Yes, here's our memory. Can take it out here. I just want to make it a little bit bigger. So here's in the memory. So let's dive line by line to see what we'll get here, the accuracy, and definitely if you can get all those numbers from there. So as you can see, if you start reading line by line here, it's the 18. You can see it is stored in R1 from here. Let's dive into the next line. Here is the 21, 29 definitely. We can see the R0 stored will be the A, and so on. You can see clearly in here. So we can see clearly here all those addresses from 0 to 29 been stored in all respective accumulators, and it can show us in the memory table in here clearly. So thank you.